So more on slopes of lines and y-intercepts in particular, because that has a very helpful graphing connection. The slope is kind of like the angle of the line. The y-intercept is like kind of that starting point or that initial value. So for instance, if you're getting a dishwasher repaired, costs $40 in parts plus $30 per hour in labor. So let's find the formula for such a cost. So we'll say C for cost would be based on, well, $40 just for the parts. And that's a flat cost. That's just what it is. And then plus $30 per hour for labor. So it's not just $30, it's $30 per hour. So that would be plus 30 H, because if it's 1 hour, it's 30 times 1. If it's 2 hours, it's 30 times 2 plus the 40 and so on. So we've got our formula here. So 0 hours would still have a $40 cost. So that would be like, say, you fixed it yourself, but you still have to do the $40 parts, but you didn't have to hire anybody. However, if you start hiring somebody, so like, and it takes them an hour, then that would be 30 times 1 would be 30, plus the 40 would be 70. If it was 2 hours, it would be 30 times 2, which would be 60, plus 40, giving you $100. Or if it was 3 hours, well, 3 times 30 would be 90, plus 40 would be $130. So if I were to draw the graph here, get this on the axis here. We'll just do kind of a quick sketch to, so that's H and C for your cost. Let's go out to, say, 5 hours. So that would be like 1, 2, 3, 4. 1, 2, 3, 4 hours. And then the cost, well, if it was 5 hours, that would be 150 plus 40. So like, we'll say we go up to 200. So that means in the middle is 100. In the middle of that would be 50, 150, and so on. So let's plot those points. 0, 40 would be right about there. Then 3, 130, or maybe 2, 100 would be a little bit easier to draw, because that's right on the axis there. All right. And remember we said 5 would have been like 5 would be 150 plus 40 would be like 190. Oh, I messed up something there. Let me back up, because I realize I was looking at the wrong number on that last point. So yeah, 0, 40, 2 would be 100, so that's up here. There's my 100. All right, and then 5, 190 would be somewhere around in here. So we got our graph looks something like that. All right. And then so let's try to circle the y-intercept on the table. So remember, the y-intercept would be 0 something, so 0, 40. And if we do that on the graph, that would be that point. And actually in the equation, keeps jumping to my eraser, that would be right there, the 40. So it's 0, 40. The 40 shows up there. Let's put a box around the slope in the equation. Well, that would be 30. That's the rate of change. It increases by 30 for every hour. And if I were going to do that in the graph, we would be seeing it here. It would go up 30 every one. So that up 30 for every hour would show up each time. So the up 30 over 1 each time. All right. And actually we see the 30 in these numbers here as well, because 40 plus 30 is 70, plus 30 is 100, plus 30, 130, and it kind of goes on from there. All right, so let's try this one here. It says Aria gets an allowance of $7 per month. It costs her 50 cents per video game at a mall arcade. So if she plays 0 games, she has $7 left. If she plays 1 game, she has $6.50 left. If she plays 2 games, she would have $6 left, or $5.50 if she plays 3 games. So she's kind of spending that money and then taking that away. So let's try to draw the graph here for this. So let's make that a 10. Halfway would be 5. So then you would have 6, 7, 8, 9, 4, 3, 2, 1. So that would be the money. And down here would be G for the games. All right, and we got to kind of figure out how many games to go out to. Well, it might be noticing that, like, oh, well, how many games could she play for $7? Well, if it's 50 cents per game, then that means she could get 2 games per dollar. So $7 would be 14. So why don't we kind of go out to like 15 here to kind of see that graph hit its ending. So let's see, we would have about a third of the way would be 5, 10, 15, right? We're somewhere in that ballpark here. All right, so let's plot those points. 0, 7. 2 would be 6. And remember, we said 14 is when she runs out of money. So you get a graph that looks about like that. So we can kind of do the similar thing here. The y-intercept would be the 0, 7 right there. And in terms of an equation, I think here this would be m equals $7 minus 0.5 G, because it's minus, because you're spending, that's decreasing the amount of money you have left, 50 cents per game. So in that case, our y-intercept would show up as that 0, 7 in the equation as well. Now the slope would be the box around that. That would actually be the minus 0.5. And we see that happening here. That goes down 50 cents. That goes down 50 cents. That goes down 50 cents. And in terms of per game, instead of going like here, you went down $1 for every 2 games, or we could see down $1, or excuse me, 50 cents for 1 game, or even down $7 for 14 games. Those would all still be equivalent. So if I write that out, if I went negative, what did we say? $1 for 2 games would be the same as negative $0.50 per game, which is actually also the same as negative 7 over 14. These would all be equivalent fractions. So that's why that slope shows up consistent as negative 0.5 in any one of those iterations. Now the x-intercept, that would be that point here. That's how many games she can play before she runs out of money. So the x-intercept would be 14 games to run out of money. All right. So the slope-intercept form of this line, we actually kind of wrote it already. So actually we've been using the y equals mx plus b as well. So we'll say y equals mx plus b. And so m is the slope and 0b is the y-intercept. So to just kind of circle those again, the b is your y-intercept, but notice that's 0b. And the slope is your m from the equation. And so you can do that as b plus mx or mx plus b. Either form is really the same as long as you keep the signs consistent.